I'm going to quickly talk to you about some of the research activities that we've been doing for medical compliance for AI in the last year. Next slide, please. So this is me. My name is Jane Orme, and I'm a software engineer at Bluefruit Software, and we're based down in Cornwall. We are embedded software specialists, and we currently have 75 employees. So I'd like to emphasize that I'm not an expert. We've been doing AI for 1 year, working on an internal project called ACE, which we say stands for Audio Classifier Equipment. We take real-time audio and classify the sounds that it can detect. Next slide, please. At the start of our project, we identified some of the main challenges for AI regulation. The first that we thought about was the proving that the AI model was reaching the correct conclusions, which is quite hard if it's black box. So we wanted to not just rely on the test set, and this is because compliance, and in particular medical compliance, you don't want to have any mysteries happening within your software. And we also noted that the dynamic nature of the machine learning is another challenge, and this is because the model needs to regularly adapt to different changes. Next slide, please. Next slide, please. Thank you. So why do we want to know the internal workings of the AI model? And the goal here is to identify the problems early so that we can do a review, and we would do a code review similarly to how we might do. So we do a model review similarly to how we do a code review. For the opacity of black box algorithms, we can use deconfnets to see which filters the model has activated. And we can also use a GradCam to develop a heat map, which will show you the areas of the sample that the model is most focusing on. And I'll talk a bit more about that in a minute. For the dynamic nature of machine learning, we realized that there are parallels with Agile, and this is because it needs to cope with the regular changes. As a company, we've already got experience with applying TIR 45, which is the Agile for Medical Device Software standard. So we have applied some of this to our project. Next slide, please. What you're looking at here is an image of an audio file. In particular, this one is a 5-second sneeze, and the sneeze sound itself happens towards the start of the audio file. So we've converted the audio into an image. This is called a spectrogram. The x-axis of a spectrogram is the time, the y is the frequency, and the brightness is the volume at that frequency. So on the left-hand side of the screen, you can see our initial model. The original spectrogram is bottom left, and next to it is the heat map. And the heat map is showing that actually it's not focusing on the sneeze sound itself, it's focusing on the silence that happens after the sneeze, which is not really how you want to identify a sneeze. So we were able to remedy this. We added a silence category, did some retraining, and you can see from the images on the right that the heat map itself has actually moved slightly towards the start of the clip. So now it's actually overlaying with the sound of the sneeze itself. Next slide, please. TIR 45 mentions the different software development activities that need to take place, but actually it's quite flexible about the frequency and the order in which these activities might happen. So you'll have your design inputs, which might be your requirements or your design diagrams and that sort of thing. The output might be your binaries, your source code, or your test results. And TIR 45 says that if you're controlling these things, then you can finalize and approve them later towards the end of your project. Which is a bit controversial if you're used to working in a more traditional way, where you would approve all your requirements and all your design and everything up front before you start your development. The image on the right actually comes from TIR 45, and it shows your design inputs and your design outputs iterating as you learn new things. So what this means is it gives you the chance to experiment. You can try different design alternatives. You can adapt to feedback, perhaps from your user or your stakeholder. And also you might want to do further model training. You might find that your model, which works really well on your computer, gets good test set results, but when you try and run it on a device, you get slightly different results, so it gives you the time to do that. You can get different tools to help you. For example, Git can enable you to store and control the inputs and outputs alongside the code. Living documentation enables you to automatically generate the documentation. And test automation enables you to automate your requirements, which is called executable specifications, to generate test results. Being alongside the code means that they match the implementation and retain the traceability. And this enables you to iterate faster while being in control, improving quality, and enable shorter release cycles. Next slide, please. And I think that's the last one. Feel free to contact me.